big one. Do you guys see all the three little triangles? And they're all right triangles. Okay, so that's the thing to remember, is that they are all right triangles, because if this is 90 over here, what's over on the other side? This is also 90 over here, right? And so we have three triangles that are all right triangles. Now, when you start these triangles, it's going to be important that you always start with the big right angle at the top. Start with the big right angle at the top. So you're going to turn your paper and actually write upside down, which is fine. Start with a big right angle at the top. Now, each of these pieces, you can see all the red letters, they all have specific names, okay? These names are never going to change. They're never going to move around. As long as you have the big right angle at the top, these sides are never going to move around. All right, so let's label them with what they actually are. Let me get a different color here. All right, over on the right side where segment M is called the right leg. And we're going to use RL. And if you need to, it's the right leg. So what do you think K is? The left leg. All right? So K over here is the left leg. There are two of the three biggest segments. So we're looking at the big triangle right now. So in my big triangle, don't mark this on yours, but this is what we're looking at right now. Okay, so we have the right leg, the left leg. Then what do you think W is way down here? Do you guys remember what we called that? Not the base. I mean, it does look like a base, you're right. But it is across from this right angle. And across from a right angle, do you remember what that's called? Yep, getting there. Hypotenuse. Okay, so we call this the hype, which is the hypotenuse. Hypotenuse is the name of the side that is across from the right angle. Now, since we have three right angles, technically we have three hypotenuses, but we're only going to consider the big one as a hypotenuse. Okay? All right, then we have what we're going to call down X down here is going to be your right segment. Right segment. So if X is your right segment, what do you think Y is? The left segment, okay? So we'll call this LS for left segment. And then what is the only thing left we have is P, the thing right down the middle. Do you remember what it's called when you started a vertex and you go straight down to make perpendicular? What's that called? Altitude. Yes, altitude. Okay, so P is going to be our altitude. So these, what is that, These 6 pieces of a triangle are never going to change. They're never going to be in a different order. Even if your triangle looks like this, where the right angle is over here, and do you see how this side over here looks smaller than this one over here? Okay? The one over here on the right looks smaller than the triangle on the left. But this is still going to be your right leg, your left leg, your hypotenuse. It's still going to be the same. Okay? All of that is still the same, no matter if your triangle looks like the one on the left or the one on the right. Okay? All right. We have some proportions. We spent all last chapter talking about proportions. So we have some proportions, because what we're going to have to do in this problem is they're going to give me only like 2 pieces of a triangle, and I have to find all the other pieces. All right? And so we're going to use what we learned yesterday about the geometric mean, about cross multiplying and taking the square root. We're going to use that same concept with this. So these proportions are what you need to write down. They're never going to change. So the first proportion is going to say left seg over left leg equals left leg over hypotenuse. In this proportion, which segment is the geometric mean? What would you say? Remember that if you look back at your notes from yesterday, x was the geometric mean, right? It was on the bottom and then on the top again. So which segment do we have on the bottom and then on the top again? Left leg. So in this proportion, left leg is going to be the geometric mean. That's what we call that. Okay, likewise, we're going to have right segment over right leg equals right leg over hypotenuse. So what's the geometric mean in this group? Right leg. Okay, the third and final geometric mean proportion we're going to have is left seg over altitude equals altitude over right seg. So we have 3 separate problems that we're going to work with. And based on the information you're given, you're going to be able to figure out what's the missing piece. Okay? So this part A of your notes is huge. Not only is it the diagram, but it's also telling you what geometric means go together. And you're going to need to remember that. Okay? So if we go down a little bit, part B says geometric means are created. And so if we look at this, let me get out of this notation. All right, so it says the what is the geometric mean for what and what. All right, so we actually just discussed this. We said first the left leg is the geometric mean for which 2? What 2 pieces does the geometric mean the left for? Left seg and hypotenuse. Do you guys see where that came from? Because we have left seg over left leg equals left leg over hypotenuse, right? So we just said that left leg was the geometric mean for left seg and hypotenuse. Vanessa, these notes are on your table up there, 5.1. We're on the back. Okay, what's another geometric mean that I have here? Right leg. And right leg was the geometric mean for what? Right seg and hypotenuse. And my third and final geometric mean was the altitude. And the altitude was which 2? Left seg and right seg.
So it was left seg over altitude
Yep. Excuse me. All right, so let's do an example of this. All right, so we have a triangle here. And I'm going to do an example. Now, notice on this example, okay, your right angle is where? Where's your right angle?
at the bottom.
It's at the bottom, right? The big one, this guy down here. Whoops. This one down here is the one I'm talking about. You don't need to circle it. But what I want you to do is I want you to make this go to the top. So what I'm going to do, yep, doing it. I want you to do this too on yours. Turn your paper upside down. Come on. Okay, just a minute. So now I want you to label left seg, right seg. Okay, so we know that over here is my left leg, right leg, right seg down here, left seg, y is going to be my altitude, and 15 is my hypotenuse. Now, you're going to be writing upside down on your paper, and it's going to be okay. I promise it's going to be okay. Okay, so the first one I want to do, let's set up our first proportion. So our first proportion is going to be left seg over left leg equals left leg over hypotenuse. So we're going to fill in this information. So if I look on my diagram, my left seg is how much? 6. It looks like 9, right? Over here, the left seg looks like 9, but if I put the diagram back to what it was, if I flip it back around, it's actually 6. So be careful about that. Okay, so we have 6 over our left leg, which is what? X. Equals X over the hypotenuse is how much? 15. And can we solve this now? Okay? You all should have your calculators. If not, go grab them, please, quickly. So I get x squared equals 90. How do we get x by itself? What do we have to do? Take the square root. Now, do you guys know how to do the square root on your graphing calculators? You hit second, and then it is the x squared button. If you hit second and then the x squared button on the left, they'll give you the square root sign. We do the square root of 90, it doesn't work. We get a decimal, and boy, aren't you glad yesterday we practiced how to simplify radicals. So how do I simplify this radical? What do I need to do? All right. All right, we're going to break it apart. Remember doing this yesterday, Adela? Your favorite thing? So I have a pair of 3's, and that means that the 3 comes on the outside. I'm left with 10 reduces to 10, 2 and 5, but that doesn't get me anywhere. So my x value is 3 radical 10. Okay? We're going to do the other ones just the same. The other proportions just the same. So let's set up the second proportion, which was right seg over right leg equals right leg over hypotenuse. So we have z over w equals w over 15. So did you guys have z over w equals w over 15? This is a problem. I can't solve this because I have 2 variables, right? However, don't we know that the hypotenuse is 15? And if the hypotenuse is 15 and I've already used up 6, how much is left for z? 9. Right? So even just by looking at my diagram, I know that z is 9. They asked me to find all of the variables, so off to the side somewhere I'm going to put that, I'll put it down here. Z is 9. But now I can substitute it into my equation, right? So I can have 9 over W equals W over 15. Okay, go ahead and solve that out. Cross multiplying.
How did you get Z as 9?
So back over here on our diagram, we said that the whole hypotenuse is 15, right? I've already used up 6 over here.
Okay, 6 is given.
Right, yeah, 6 is given. So I just did some subtraction. Do you have the notes from yesterday? Okay, grab them out, please. Does that make sense, Colt? Okay. 9 times 15 is 135. Okay, go ahead and break 135 down. Now, if you don't know what goes into 135, just try 5, because we know 5 is going to have to go in there. So 3 goes on the outside. What do you guys have for the inside? 15? I would agree, because you have this 5 and this 3 that can't be multiplied by anything. So 3 radical 15 equals W. See if you can find the altitude, which is Y, on your own. We're getting Y to be 3 radical 6. 3 square root of 6. Excellent. All right, any questions on this now that we've done our first one? Yeah, because they asked us to find all the variables. Well, okay, you didn't see the directions because I didn't write them on there. But they're going to ask you to find all the variables, okay? And there isn't a lot of work to do for not a Z because we just did some subtraction, right? So there might be some variables where you don't have to do this whole big long thing. You can just do some subtraction, okay? Good question. All right, no other questions on example 1? Okay, let's go down and do example 2. Now, this one's already kind of sideways, so we don't really need to move it necessarily. So let's label everything that we know for sure. So we have left leg over here, right leg up top, right segment, left segment, altitude. Now my hypotenuse is not given to me, right? But I know that whatever this is going to be my hypotenuse. Would you agree if I knew what C was, if I told you that C was 10, I could add 5 and 10 together, the right seg and the left seg together to get my hypotenuse, right? But I don't know what C is yet. Okay, that might come later in the problem. Okay, so let's go ahead and set up our proportions. So left seg over left leg equals left leg over hypotenuse. Five what? You could put that for your hypotenuse. Let's talk about that. So we have 5 over D equals D over, and Adela said, can we put C plus 5? I think that would be a good idea, because that's my hypotenuse, right? My hypotenuse right now is C plus 5. I don't know how long it is. Now, if we look at this proportion, I have a D and a C value, and I don't know either one, and I can't just do a subtraction problem. So this problem can't go any further until we figure out what D or C is, correct? Okay, so we're going to leave this as is. We'll come back to it. Let's try to set up the second proportion and see if we can find from the second proportion one of our variables. Okay, so the second proportion, right seg over right leg. And again, I'm getting C's and B's. Is that what you guys are getting? C and B, and we can't do anything there. So now we're praying and hoping that our third proportion actually is going to get me somewhere. Okay, so we'll leave that one alone, come back to it. Whew. 5 over 10 equals 10 over C. Is that something we can manage? We can do that one, right? Okay. So when we cross multiply, I'm not getting an x squared, right? I'm getting 5c equals 100. This is a basic algebra problem, right? 5c equals 100. So if we want to get c by itself, we're just going to divide by 5. So what are you guys getting c to be? 20? What's the number I was looking for? C is 20. So if C is 20, can we go back and fill that into my first two proportions? Okay, let's go back to number 1. Okay, let's go back to our first proportion. I'm going to have 5 over D equals D over, I said that C was 20, so what's 20 plus 5? 25. Right, we said C was 20, so we plugged it in. 20 plus 5 is 25. Are you guys getting D to be 5 radical 5? Okay. All right, why don't you plug in and find out how much B is? Why don't you plug into the second now? The second proportion. Find out how much B is. So I get B to be 10 radical 5. Is that what you guys have? Excellent. All right, so we have C is 20, B is 10 radical 5, and D is 5 radical 5. How do you guys feel about that? That was not a rhetorical question. You're okay? Any questions on that? It's really just setting up your proportions every time the same way. Making sure that this big right angle, guys, this big right angle up here is at the top of your paper. If that big right angle is at the top of your paper, everything else should match up and you should be good. All right? You're going to need to know these that are in blue, right? You're going to need to know those. Those don't change anytime. All right.